symbol up here, and then you have the variable k equals 0. So what this means is obviously is that every time you do this, you're going to be starting at 0, and the next time you do it, this is going to turn into 1. Then this right here is gonna turn into 2. So 1, 2, 3, 4, etc. And it's gonna go on forever. It's gonna go on forever, infinitely. It's never gonna stop. So once it gets to 1,000, it'll go to 1,001. You know what I mean? So every time you do this, you substitute the k for 1, 2, 3, 4, etc. So k becomes 1, k becomes 2, k becomes 3. So the first time you do it, it's going to be 0. And that's how you get the next decimal place of pi, okay? So using this algorithm. But there are actually more ingenious and more simple algorithms than this. This is just an old one from an Indian mathematician. And they actually stole this from this mathematician and published it in like an English newspaper. They published it in an English math journal later on, but they did steal it from him. But then they gave him like credit later on. But then they really hid like a lot of his other works, I guess, too. So obviously this just means that you're gonna do that, and then the k becomes like 1, right? So you just erase it. Okay, and then this is a k, so you erase it, right? And you put 1. So again, we could do like 0. We could start at 0, or we could start at 1. But what it is you're going to be multiplying it, you know? So you would do this, and then you divide it, and you end up with a number, right? And then you're going to take this part, and you do 4 times, if it's at 0, you do 4 times 0 inside of this, and then you do the 1 to the 4th, right? So 1 or 0 to the 4th, which would be 0. If it's 1 to the 4th, it'd be 1. If it's 2 to the 4th, you know, it'd be like 2 times 2 times 2 times 2, right? So and then once you have these numbers, you divide them. You can divide them from the top to the bottom, as well as the bottom to the top. That's all it is. That's all fractions are. It's a division problem. Okay, so if you divide it reverse, you actually come up with something called inverse pi. You do the same thing over here. You do 26390 times 0, because it's starting at 0, or if it's at 1, you know, you replace it with 1. So it'd be times 1, times 2, times 3, etc., right? And then you add it to 1103, and then you do 396 to the 4th power, right? And then times the 1, or times the 0. And then you end up with a number down here, and you end up with a special unique number down here. And then what you do is you divide it from the top to the bottom, or the bottom to the top. And what happens is you actually get the next decimal place of pi when you do that. So you end up with 3.14, right? And then you get the next number of pi. You literally get the next number of pi infinitely. So it goes on forever, right? And this is just one algorithm to get the next number in the infinite decimal places of pi. So pi is like, they use it for all kinds of stuff. They use it for precision, like atomic weighing and stuff like that, I guess. I mean, they use it for all kinds of cool stuff, you know? And you can make like all these like seemingly perfect like shapes out of it, but really there's no such thing as a perfect shape. It's just imaginary, you know? It's never completely perfect, even when it's naturally made, you know? So like when it's like naturally made in like the universe, you know? I'm gonna get into all that stuff. So this is just an example on how to lightning mentally calculate pi. to get the next decimal place. So you can do it in your mind. Once you memorize this, you can do the operations in your mind to get the next decimal place of pi. So it depends on like your computation time. Your mental computation time is like, well, how long does it take me to add, 10 plus 10 in my mind, okay? And then you take all of those factors and you say, well, how long does it take me to do this mental computation to get the next decimal place of pi? And it's actually not hard to do once you have this memorized. Once it's memorized, you can actually do this to get the next decimal place of pi in your mind. It's not hard to do it. It'd probably take you about maybe, I don't know, 1 to 2 to 3 days to fully memorize and understand this at the fundamental, at the most like the best like fundamental level, and then you just play with it, you know what I mean? You play with it in your mind all day, and after you do that, you can get the next decimal place of pi. That's lightly mentally pi calculating, okay? But also, I just showed you how to solve just about every math problem out there. It doesn't matter how advanced it is, or how quote-unquote advanced it is, or how quote-unquote complicated it is, right? So if you refer back to like another video that I made, I showed all of the different possible parts of a mathematical expression, mathematical statement, mathematical equation, mathematical, etc. All the different parts of it, so you can like identify all the parts, right? So like you have like the factors and like, like whatever, and then like PEMDAS, like you do like the parentheses, exponents, multiplication, the division, the addition, and the subtraction, right? But also in that video, you'll see that it's actually possible to get multiple correct answers out of one math problem, because when you apply different like rules and stuff, you'll end up with like different answers, products, sums, etc., right? But it's also possible to get, multiple correct answers out of it, and all of them are correct at the same time. So not just one answer is correct, they're all correct, depending on which rules like you apply, right? So if you solve it all different ways and list all of the different possible like outcomes, then you can then evaluate all of the possible like outcomes from that. Okay, so we'll move on to like the next video,